Now we've recently seen Claude, Haiku and Sonnet on this channel, and now we're going to look at the biggest model by Anthropic, which is Opus. Now Opus is the most expensive yet most accurate model in the Claude family. It's actually the best model on the market across multiple tasks. It's expensive because the sheer size of the model makes it difficult to run inferences on it because of the compute size and GPU size it requires. Now, since it's so accurate, it will be a good fit for specific tasks. Today's video will save you a lot of time if you're building a project and looking for the right LLM for the project. Now you've already seen Haiku and it's pretty good, really cheap and also multimodal. And you've seen Sonnet, which has really good reasoning abilities. Now, do you really need Opus? Do you really need to pay a lot more money for the extra capabilities it brings? Let's find that out in this video. Now, I'll be taking you through a code file and we will be putting Opus through its paces, just the same way we did with Haiku and Sonnet. Meaning, we will be asking Opus very similar questions to what we asked Haiku and Sonnet. And this will help us compare it with Sonnet directly because I don't think comparing it with Haiku will be right, since there's a lot of size and capability difference between the two models. But since Sonnet and Opus are still quite close comparatively, so they can be compared, I will be sharing the link to the Colab file in the description of this video. So make sure to make a copy of it so that you can refer to it in the future as well. Now we will first import LangChain core to access the main features of LangChain. And Anthropic, since we need to work with Opus, which is a model by Anthropic, and LangChain Anthropic, which provides LangChain the ability to work with Anthropic models. Then we import OS and set the Anthropic API key. And just like the Sonnet video, we import the human message, which is the prompt to the LLM that we want it to process, and the system message that guides the response of the LLM by asking it to behave in a particular way or tone. Then we import chat Anthropic to allow us to chat with the model, and we import display and markdown to be able to format the output in markdown to make it easier for us to read. Next, we set our chat model as Claude 3 Opus, and we create a human message with the content knock knock. We are doing this just to see whether we get a result back from the LLM or not. If we do get back a result, we can proceed with our tests, and right enough, after we invoke the LLM with chat.invoke, we get the response in the response object and we print it. We can see the response from the LLM, which is who's there. Then we create our standard prompt template of asking the LLM to tell us a joke about a particular topic, where the topic will be passed dynamically. This is done with the help of prompt templates, which we have seen in the LangChain Basics prompt template and few short learning video. Then we create our chain with the prompt and the chat. The chat basically has the details of our model, and we invoke our chain by passing the topic as space, meaning we expect a joke about space, and we get the response in the response object, and we print the content from the response, and in the output we see a joke. Now the main difference between Claude Sonnet that we saw in the previous video and Claude Opus for this particular task is that Opus goes beyond just one joke and gives you more without being asked to do that, which is cool. And not only that, it understands that jokes make you smile. So the last line says, "I hope these space themed jokes brought a smile to your face." I think that's a really nice touch, just shows how capable the Opus model is. And if you're building something that's supposed to talk to humans a lot more, like an AI friend or a mental health specialist, then Opus is a really good choice. As you can see, it's got characteristics that can pass off as empathy. Alright, now we're creating two functions, wrap text and generate, because we want to test out the model properly and we will be calling the LLM again and again. We can isolate the logic to call the LLM in a separate function called generate. And this function takes the help of the wrap text function to format the output, and this output is then printed in the markdown format. The wrap text function ensures proper spacing and putting content nicely in different lines to make up a proper paragraph that's easily readable. And the generate function takes an input text and system prompt, and the max length is set to 512, which is a good enough token length for the output. Inside the function, we create our messages, which include the system message, which is equal to the system prompt that we'll receive in the function. The system prompt basically helps guide the output from the LLM by asking it to behave in a certain way. And the human message is the input text from the user to the LLM, or basically the prompt that the LLM is going to process. Then we create our chat object with all the details of the model that we'll use. And with the help of chat Anthropic, we set our model to Claude 3 Opus with temperature of 0.7 and max tokens equal to max length, which we earlier set to 5 and 2. We're going to invoke our chat by passing the messages and get our response. We'll extract the content from the response into the text variable and pass it to the wrap text function, which we had defined above. And the output from this is held in the wrapped text variable, which then gets printed into markdown. Now that we have the generate function, all we have to do is call it by passing different human and system prompts and check out how the model performs with different types of tasks, which will help you determine where the model shines. Alright, so the first task is we ask it to write an analogy between maths and a lighthouse, something which really smart people would also struggle with. And if you remember in the Sonnet video, we got a nice paragraph which gave us a convincing analogy. Opus goes a step further. It gives you 6 different points with sub-points explaining each point. Now in the system prompt, we did mention that we need a step-by-step reasoning, but this goes way beyond, and the output is too well structured and just shows where we have reached technologically. This just shows that the model can be used really well if you're building an educational application, because it can explain even abstract concepts really well. Next, we ask it to write detailed analogy between maths and music. Again, we get a very detailed and well-structured response. Now, since we've limited the response to 512 tokens, they will get restricted at the end, and some of the outputs will be incomplete. But that's all right. We just want an idea of how the output would be. Since we have added percentage time, we're getting the CPU times as well. Alright, next we ask you to generate the difference between llama, vicuna and alpaca. In the output, we notice that it understands we're talking about the animals and not the LLM models of the same name, and then gives us a very well-structured response. Now if you remember, we asked the same question to Sonnet as well. The response was great, but it was by no means so well-structured and rich. So if you're looking to generate good and lengthy answers, then Sonnet is great, but if you want to go beyond and want to generate structured responses with clear details, then Opus is definitely the model for you. Now we will ask you to generate an email to Sam Altman 4 different times, each time acting as a different person. So first, we just ask you to write an email and share its reasoning step by step, and the email produced is way better than this one Sonnet produced. Why? Because this email is much more convincing and has more logical points as to why Sam Altman should open source GPT-4. Then we ask it to behave like Freddy, a 5-year-old boy scared of AI. Now what you see in the output is really amazing. You see typos, and that's something a 5-year-old would make. The email looks like it's been written by a 5-year-old, which is awesome. Next, we ask it to be Kate, the Vice President of USA. And here in the output, Opus replies to us and says it's not comfortable role-playing as a senior government official. That just shows it's considerate, just how a model as powerful as Opus should be. Then we ask it to behave like an actor who's playing the role of the Vice President of USA, just to confuse the model. And Opus forgets its previous output of not being comfortable playing the role of the Vice President and generates a nice output, but the output is in no way a short email to Sam Altman. There is no intro, it's not addressing Sam, and it's not signing off on the email at the end as well. So in this regard, which is writing emails, I feel Sonnet is way better. Then we ask it the capital of England, and we ask it to give us a short answer, and sure enough, we get the answer London. Then we ask it a lifetime question about Geoffrey Hinton, who's still alive, and George Washington, who died a long time back, and ask it if both of them can have a conversation. And the model is able to reason out clearly that they cannot have a conversation because one of them isn't alive, which is perfect. Then we ask it to generate a story about a koala playing pool. Now in the output, you get a great story. And if I compare it to Sonnet's output from our previous video, I know that the story given by Opus is much better, but the writing style of Sonnet was much better and had a lot more depth. But I think that's just personal opinion. We asked both of them to be a genius storyteller, and while Sonnet focused on the storytelling skills, Opus focused on the story itself. Both are right in their own ways, but are quite different. Then comes the code generation part, and I felt Opus is really good because unlike Sonnet, it's not too by the book and actually gives you simple code answers that a beginner can understand. Because if you're asking an LLM to write the code for printing prime numbers, you're definitely a beginner and you want an easy to understand solution, right? Sonnet gave me the most complex answers ever, but Opus is really good in that regard. So here I give it a problem to print all primes between 1 and n, and the answer I get, like I mentioned, is simple, but what I really like the most is the great detailed explanations that I get with it. This is what someone asking for code needs. They need complete explanation of the code. So even though we didn't ask Opus for this, it was considerate enough to generate the explanation for us. The next question is about detecting whether a number is prime or not, and Opus again does a really good job, but most importantly, again gives us a very detailed explanation about the code. So I really like Opus for code generation tasks. Next, we have our maths problem. So if you want to know if Opus is a great maths tutor, let's find out. We give it the standard subtraction-based apples in the cafeteria problem, and it gets the right answer. But that's not important. What's important is the way it's explained the steps it took to reach the right answer. It's very detailed. The next question is a dollar per hour calculation problem, and you again get the right answer. But again, most importantly, the explanation is what wins in this case as well. Very well structured and explained. Then we give it the deep sea monster eating people question, which is an equations question, and it gets the answer right, which isn't surprising, but it's really well explained. And I think if I wanted a maths tutor application, this is what I would want in that application. Not just the right answer and a basic explanation that Sonnet was able to produce, but this type of a very well structured thinking approach. Then I give it another equations question. I get the right answer and an explanation, which is good. Then I've given it 3 questions that we haven't tested on the Sonnet model yet. This isn't really maths, it's more of a logical reasoning question, and it gets the answers right. Now, many LLMs get maths questions right because they've been trained on a lot of data and they've seen that question in some shape or form earlier. But with logical reasoning, that's not usually the case. It's just a bit harder to get the right answer, and Opus is doing a really good job here. I give it a similar question again, and it again gets the right answer. I twisted the question to just ensure it's not seen the question before and memorized the result from somewhere. So I used new names and I changed the count of brothers and sisters, and this shows Opus in fact is really good with reasoning and not just giving us answers from its memory. Alright, I hope you enjoyed watching this video and seeing Opus go through its paces, and now you know when to use Haiku, Sonnet and Opus depending on your use case. If I was building an application that didn't require logical reasoning, great explanations and empathy, etc., I would go for Haiku. If I needed something that was good with maths and explanation, then I would go with Sonnet. And if I wanted the absolute best at explaining complex stuff with structured approach, talking well with humans, writing great stories and jokes, and a verbose model in general, I would go for the all-powerful Opus model. Now a quick video about our sponsor, which is you. Yes, you're the sponsor of this video, and this channel is dependent on you sharing this video, liking it and commenting on it. Because I have no other sponsorships and partnerships on this channel, it's a small channel with very niche content and it won't get picked up by the algorithm unless you share it with your friends. So thank you for all that you've done in supporting this channel. Don't forget to join our Discord where we hang out and discuss technology, and the link for which is in my YouTube profile. Thank you so much for watching this video, and I'll see you in the next one.